All right, let's look at modifying global variables and functions. This is an important one. And this has another example. The code's getting smaller. So we want to look at an interesting way in how Python deals with globals inside of functions. So, I mean, we have g equals 1, we set g, take some parameter x, set g equal x, return g, and then we just, and obviously this function doesn't run until we call set g. And so let's actually run it. And we print out, it's called set g with 10, and it prints out 10. So it returned 10, which we expected, right? We pass in 10, 10 goes into g, return 10. All that seemed to work fine. But let's print out g. G is still 1. Why is g still 1? How did we get 1 here? And we have our code, we have g equals 1, set g equals x. It didn't change. Let's actually look at see what happens in the stack frame. So initially, we have g, set g to 1. And in the stack, so we call set g, and we pass in 10 as a parameter, or 10 as an argument to the parameter x. And so we have set g, and inside here's an x, and x has the value of 10. We passed in that 10. And then we have g equals x. And what happens here is when you do an assignment, it actually creates a new g and sets it to 10. Essentially, Python does not allow us to modify the global. So inside of this method, if we assign to the global, we create a new local variable. This is a local variable, g equals 10 now. Globals in Python can only be modified at the top level being the left-hand side of the file. It's the only place where you can modify the value of a global variable. When you're inside of a function, you cannot modify the global. So when we assign to some variable called g, we're actually getting a second g inside of the stack frame. So set g, inside of set g stack frame, we get this new g with a value of 10. We're no longer using the g inside of the global. So this g is also hiding this g. So when we do the assignment, we get this new thing. Always create a local when we do assignment in a stack frame. And then as soon as we do that, from this point on, g is now going to find it in the local stack frame. And so this is going to return 10. Because it's inside the local stack frame, and we always look in the local stack frame first before we look in the globals. So that's a bit of a tricky thing right there. And there are other ways of doing this, right? There's some things, some tricks we can do to do that. But there's only one way to modify a global. Now, one of the things you can do is what if instead we know we can modify a list inside of a function, right? So instead of making g an integer, actually let me make a copy of this. Save as set g2. So what if instead we made this a list? And instead of doing g equals x, what if instead we do g0 equals x? Now we save that. So instead of making G an integer, we're basically making G a reference to something. And we know we can modify the contents of a list inside of a function. We're no longer assigning to X or G. We're now using X and assigning that to this, it's looking up index 0, and it's going to modify internally what's going on. So it's actually going to modify this first element. So we call set G the value of 10. It returns the list, because we return the list. If we didn't want to return the list, we want to return just the value 10. We can do that as well. Now it returns 10, but if we look at G, we can see that G was modified to 10, 2, 3. So remember, we're not modifying G, we're modifying G as a reference. We're modifying the contents of G. We're modifying the location of index 0 to be 10. And we're just using G as a reference. What this looks like in a stack frame. Oh, I guess we could have also remove the return value. That's what I did in this code initially. But returning the value or not doesn't matter. What's important here is that when we call G equals 1, 2, 3, we get G. And then G is going to create a list. 1, 2, 3. And this is going to be a reference to that list. And then we call set G. And again on the stack. And now we have set G. And set G has X. And what value is X? X was past 10. And then when this runs, G bracket 0 equals X, it doesn't modify the variable G. Instead, it takes this value at index 0 and turns that into 10. And then this will disappear. And after it disappears, we're still left with the value of G as 10, 2, 3, because we didn't actually create a new variable. So we're just modifying the contents of a list. And the global G still has a reference to that list, and that list now has a value of 10 at index 0. So this is one way in which we can modify a global, even though we cannot directly assign to a global variable and give it a new value from within a function. Instead, we use a global variable as a reference, something like a list, and use that to modify the contents of the list. And if we really wanted to be tricky about it and we didn't want a full list, we could have literally have just made this a single element. Instead of trying to, and then G only has one thing. So instead of actually passing or trying to change it internally, we just make it a list, change the list, and then the value gets changed. So remember, this is just a reference now to an object called a list. We can update the contents of a list from within a function, which even if it's a global variable, and it'll just modify that contents. Questions on that example? It's a little confusing about what's happening there. But essentially, we're just kind of tricking it. Remember, this first example here, we could not modify the global. You cannot modify the global variable from within a stack frame. You can only modify a global variable within the top level of a program, which is where globals are actually defined.